So what I want to cover next is peering analysis and planning. And let me...
And while Jim is getting that going, I'll just say, we run into a lot of people, that of course connect to the internet because it's, now everyone say ooh after I say it, SD-WAN. Ooh. But CDNs, users are there, but also a lot of enterprise don't realize how many applications they have that are dependent on Twilio, Google Maps, other enterprise sources. And so there's a lot of people that think I have my network and that's all there is, and the internet is this thing over there, but it actually does tend to be pretty important, not only for SaaS apps, but for your own apps. So service providers, they get this, what Jim's about to talk about, but a lot of, if you're consulting and working with enterprise, people underestimate how important the border of their network is.
So aside from the real-time, kind of ad hoc, drill down, investigate, troubleshoot, one of the other big use cases for our platform is peering analysis, interconnection analysis, capacity planning, and this goes for both carriers, large service providers, but also for content source networks. So either they operate infrastructure that delivers their application, streaming video, streaming audio, whatever it is, or CDNs themselves, right? We have several large CDNs that are our customers. And so for those folks, optimizing their network for cost, for performance, in terms of how they interconnect with the destinations they reach is a super important part of how they do business, right? Because the quality of their connectivity really impacts how they deliver their service and their revenue. So we looked at before how we have all of the flow data correlated with a number of other data sources, BGP data being one of those. So at a really simple top level, I could say, show me traffic by destination AS number. And what we get in both the graph and the table is color band and a table row for each of the unique destination ASNs that we're seeing. By default, we don't apply any directional filter to this. So we're looking at both the inbound and outbound traffic combined. I can easily apply a directional filter, though. One easy way is just to exclude traffic that goes to my own ASN. So now I can see traffic volume to remote ASN. Beyond just dest AS path, I can also beyond dest ASN, I can also see things like destination AS path, and then in the filters, I could look at things like specific ASNs. So I could add another filter on top of this one that says only show me the dest AS paths that include AS 701, for example. And now I've got only paths that contain that AS number somewhere in the hop. So these ad hoc queries are great for kind of point-in-time questions. How much traffic do I send to this ASN? How does it get there via which path? Those sorts of things. We also wanted to build kind of a big picture peering analytics functionality, though, and that's over here in the analytics menu. And this functionality allows you to create a data set that combines the output of multiple queries, and you can add filters to it. So I could build a data set that looks just at traffic at one pop. It could look at traffic at one region. It could look globally across my whole external edge. So once I've got the data set built, it takes a few minutes to punch the numbers, and then I get output that is displayed in a Sankey diagram like we saw before. And so this is actually Kentik's own network. Let me reduce the...
Helps have more resolution.
Yep. It's nice to look at it on a big screen. So what we're seeing here is actually Kentik's own network. The blue bar is our primary POP in Ashburn, Virginia. The next column are the ASNs that we are directly connected to, either as peers or transit providers. And the remaining columns are the top ASNs that are 1 hop, 2 hops, 3 hops beyond our existing direct connections. And so visually, it makes it pretty easy to identify the best candidates for interconnection. How could I move traffic off of my paid IP transit links and deliver it directly to the end ASNs? Or maybe there are middle hop ASNs that would be a good candidate for peering as well. There's a lot of tools, especially open source tools, that'll show you traffic breakouts by destination ASN, but rolling up all of the traffic for the middle hops is a more difficult problem. And it's some of those middle hops that present the best options for interconnectivity. Of course, you can save money if you have less traffic going out paid IP transit and you move it over to cross connects or whatever. But also performance is a major reason for people engaging in interconnection as well. So if you can eliminate middle hops and deliver traffic directly to the endpoint, obviously fewer hops, less latency. Also resiliency in that you have now more paths to any given destination. And it may not only be settlement-free peers that you choose to interconnect with. Like just in this example, I can see we have a lot of traffic that ends up to or through Cogent's network. And maybe Cogent is not a carrier that I would normally buy transit from, but if I identify that I've got almost a gig of traffic that ends up on their network anyway, it doesn't make sense for me to pay $1 a meg to level 3 to send traffic to Cogent if I could get that bandwidth from Cogent directly for 25 cents a meg.
So you're doing this analysis based on the AS path you see, or the destination AS number.
That's right. So essentially we're rolling up all of the flows by the AS path that they were tagged with at the time we received them and visualizing it in a way that makes it easy to understand that data.
So US and Germany and things like that on the right-hand side are geolocated stuff?
Yes.
And then you take the AS path, how you got to the individual IP addresses, and that's the middle.
That's right.
Exploded part of it.
And if you look at it over a period of time where the AS path changed, it's really weighted per flow, because every flow stores the AS path when the flow was received. So if half of it went one path, half of it went the other, that'll be reflected there.
Oh, even that.
Yeah.
I can also click on the individual ASNs in the diagram to see an exploded view that's filtered just on the hop that I clicked on. So if I were considering peering with or maybe buying some connectivity from 6830, now I can see a zoomed in view that'll quantify, how much traffic is going to come off of my existing paid IP transit link if I were to peer with that ASN. Which downstream ASNs behind them are going to be affected by that new connectivity, which routers or devices is that traffic coming out of, those sorts of things.
So this is like visual representation of what would happen.
Yes.
Can you do it slightly more formally, saying, assuming I peer with this AS, what would my traffic structure look like afterwards?
Well, so we can't know for sure what the traffic flows are, but this is essentially giving you the answer to that question, right? So if I peer with this ASN, currently we're delivering traffic to that ASN via 23352, which is Server Central. So presumably all of the traffic that's going out Server Central now is going to come off of Server Central and go out the new connectivity. Another interesting thing that we do for peering and capacity planning is we can tag flows at the point of ingress with the router, site, and interface where that flow will eventually leave the network. And so this is something that's become very useful for IP transit providers and carriers who really want to understand for a customer port or across a bunch of customer ports, how far do I carry that traffic across my network? Unfortunately, in our demo environment, it doesn't look a lot like a big IP transit provider, but I have a slide that kind of indicates how that looks in a customer environment where we have this enabled. So we've got some dimensions that you can group or filter by, which we call ultimate exit site, ultimate exit router, ultimate exit interface. And when I group by those dimensions, I can see for any given ingress pop where that traffic is going to egress. So in this example, I filtered on a particular customer using actually interface descriptions. So in this particular customer's network, all of their customer ports have interface descriptions that indicate which customer they're connected to. SNMP interface descriptions.
If you have multiple exit points toward the same destination, how do you figure out which exit point was actually taken?
So we're able to look at the BGP path, which tells us where that route originated in the network. The next hop IP associated with that BGP path is going to indicate where that route was learned. If it was learned from some internal source, then the next hop IP.
That's
No,
okay,
but today we don't do ECMP. So if there's equal cost load balancing, if there's BGP load balancing on multiple best
the problem
paths.
I'm seeing sometimes is that different parts of my network would get to the same destination through different exit points.
If there's only a single path, then we'll still track that because we're actually looking at what the path was at the time the flow came in from the device. We have a routing table per device. So
Okay.
it's not one per the entire AS.
And you hope that so are you getting the same flow data from multiple devices in the path?
Yes.
And then
I mean,
you're
they're both
correlating
sampled,
that and
so-
you're saying, oh, this is the same flow.
We are not doing the unification because most of our customers do sampled today. We can do that if it's unsampled, but if it's
Yeah.
sampled, there isn't enough to do the stitching.
Because the other problem that sometimes happens is that, yeah, I think that I'm going this way, but because BGP route reflectors and stuff, actually I go the other way.
Right. So it is important that we get the routing table that affects the router. We get routing tables for the device sending us flow, basically. The reverse we can do, which is for an entire data center, if we get server data or Nginx data, then we take the border routers. Now, if you have two border routers and you're packet load balancing to them and they each have different routing tables, then we're going to be inaccurate because we can't. It needs to be sort of deterministic. The one thing we haven't done yet that's on the roadmap that's related to that is if there are multiple best paths, right, not just one. The problem is today, both BMP and BGP ad paths are exported before policy is applied. So we have a request into Juniper. 5 of our customers have requests into Juniper, which mostly what they use. We love Cisco also, but to apply it after policy so that we can have, because I don't, again, like that, now I have to build a router to really parse. So sorry.
I assume Juniper is working on it. I know who is working on it.
Oh, okay.
You're
Yeah,
fine.
we've been told that it's coming, and then we'll probably do BGP and ad paths as a way to take the Evan's point, to take multiple best paths.
You'll have to, otherwise you're limited to single best path.
Exactly, which is an approximation.
Yeah.
So, yeah.
So in a nutshell, because we have the routing table and the flows from the same router, that routing table is going to tell us where that router is going to forward flow, and the next hop on each of those paths is going to tell us what point of egress that route was learned from. Then by correlating all of those things together and grouping by appropriate dimensions, in this example I'm grouped by source customer, ingress pop, egress pop, and next hop ASN. And from this diagram I can determine relatively at least, how far on average did I carry this customer's traffic across my network. This customer's traffic is pretty well localized, so the traffic that I received from them in Miami was mostly delivered out of the same POP or an adjacent POP in Atlanta. And same with the other points of ingress. If I have a customer where I'm accepting traffic in Miami and delivering it in Dubai, that customer's traffic costs me a lot more. And so if I'm a carrier, this is a level of visibility I really haven't had before. So I price my IP transit based on an average cost across all of my customers. Now I have the option to do kind of a cost analysis for this customer, offer differentiated pricing based on how localized their traffic is, or maybe I'm already selling IP transit that way, but I don't have a mechanism to enforce the deals I've already made or assess the compliance of the customer's traffic that way.
Since egress peer engineering become more and more popular, do you see requests to understand the semantics, EP?
We No, I think some people are. I think some people are applying their own semantics to it based on the data that we deliver, but not built into the product yet.
And if you're enterprise, then instead of customer or pop to pop, it might be group or application. What's this application? What of my infrastructure is this application user group taking on top of the infrastructure? When someone says my port is full, or my site is full, or my data center is congested, what's actually causing it? They're all just dimensions, so you can make any of these things, any of the dimensions in Kentik.
And I guess that your answer to my next question, which is what if I have 100 customers,
Yeah.
will be, yeah, you have a query, you can extract the data, do whatever you wish with it.
Yeah, we have, so if you have hundreds or thousands of customers, you can actually do sort of top by distance is something that we're doing for some folks. And again, it's all API, so you can actually just run the query and say, find the customers that are out of whack with profitability. It's not seemly to talk about, but a lot of peering analytics is also not only who could I sell to, but based on what I know, where would their traffic go and would that be profitable? Because networks cost money.
Yeah, that's another aspect of this that some of our carrier, wholesale transit customers is sales prospecting, right? So I could filter on traffic leaving all of my settlement-free peer ports and look at ASNs that are beyond the first hop. And so that's traffic that I'm essentially, I probably accepted that traffic from a customer and I'm delivering it over free peering, but what if I could now go approach the end destination that's 1 hop or 2 hops beyond where I'm delivering it and sell transit to them too? Now I can make money on both sides. And that's been a very popular use case for that customer set. The next evolution of this is going to allow our customers to apply costs. So you could not maybe dollars and cents costs, but you could think of it as economic units. So traffic that enters Miami and exits Miami has an economic unit cost of 0, but traffic that enters Miami and exits Dubai has an economic cost of 10. And then I could assign economic costs to all of the next hop ASNs as well, and then do kind of an automatic calculation for all of the traffic in a set. Maybe it's all of the traffic from a particular customer, and it'll spit out, this customer's traffic overall has an economic cost of X versus this other customer that has an economic cost of Y. Let me go back to...
You probably want the other browser.
Yeah. Then 2 other things we have here in the analytics menu that are related to peering and planning. One is what we call route traffic analysis. So we had a few different customers, especially customers that deliver a lot of content, who are interested in using low-cost, limited fib devices at their edge. And I think there's been a couple of companies out there that have done public presentations on this, but the challenge there is which routes do I put in a fib that only has 10 or 20,000 entries? And if we can look at the flow correlated with the routing table, we can actually tell you which routes deliver which percentage of your traffic and give you a sense of how big your fib needs to be to cover 99% or 95% or whatever of your total traffic volume. So in this demo network, it looks a little different than probably a real content delivery network. In our case, a single route is responsible for 46% of the traffic volume. And by the time we've added the second route, it's responsible for 80%. But what we see in a real network is a nice curve here showing that maybe at the 3,000 route mark, you've covered 90% of your traffic volume out of almost 700,000 routes in the BGP table. And then for the 5 or 10% that's not covered by those 3,000 routes, you could just use a default route to send it out transit or whatever.
And so the most advanced customers that we have will typically deploy an MX somewhere with a couple hundred gigabits as the default destination, but actually have either the servers themselves do routing, or white box switches in front that actually connect directly to the transit. They'll use whether it's Nginx logs or their own data to say where's the performance problem and actually be able to select routes in front of that default router, and even sometimes preferentially based on the application. We have customers do terabits per pop.
So how would it practically work? I know capacity of my TCOM number of routes I can have on particular piece of silicon. How can I communicate this to you? How can you communicate it back? So normally it would be in my local RIP in BGP. I would try to optimize, and I probably could do local optimization to 50, 60%. If I use you as analytical engine and provider of data, how can I integrate in something like FRR or any other open source BGP stack?
So I think a lot of our customers are using an Arista feature that allows you to mark which RIB routes you want to install into the FIB. And we don't have a direct integration with Arista, but it's not something that really needs to be done real time continuously, right? It might be a process that every 6 hours or 12 hours or 24 hours does an API fetch from Kentik to say, what are my top 6,000 prefixes by traffic volume, and then does a push into Arista.
Generally, it's 5 different Python programs that people have written that pull from our API and then integrate with whatever, whether it's ExaBGP or something, whether it's a BGP daemon to send, or API to a device layer to say these are the routes that I want.
Is there existing open source software that I could use to fetch this information from your system?
I don't know of any customers that have published Kentik integrations as open source, although it's a good idea, and we could possibly push some people in that direction.
We're happy to introduce you to, they're not all referenceable customers, but generally people love talking about their nerdly passion, so you might be able to get
Thank
some.
you.
I can talk about one customer who's on record doing something similar with our APIs, which is Pandora, who uses our platform as a data source to find interfaces, IP transit interfaces that are approaching capacity. Look at the top AS paths or top prefixes on those ports, and then push configs into their routers to move some of that traffic somewhere else. Sometimes it's not interface capacity, sometimes it's a commit, right? So they've got a 10 gig port with a 4 gig commit. They don't want to exceed their 4 gig commit, so they push that traffic to some other place that has capacity. And that happens automatically on a regular basis. And that's sort of, it kind of ties into a case where there's, n number of vendors talking about self-driving networks, and what they've provided is, APIs and that sort of thing. And in every one of them, there's a box on the diagram that says controller, but no one said, well, what's the controller, right? Which product or software provides the functionality that's going to consume the data and then drive those APIs to make the automation.
Self-driving has been TM'd by Kinetic Impeller.
It has been amazing to me that people want to do SDN and programming without knowing what the network is doing, and that hasn't been like, you don't start with what's it doing and then add in what you want it to do, and then okay, that's the delta. And as a result, most of the deployed SDN we see is basically just throwing tunnels at random over the data center infrastructure, which can create congestion if you're not really aware of what applications want to talk to what. And in some sense, it's good, because then you need an analytics tool to say, why is there congestion up to the center of my infrastructure? And it's just going to be an interesting evolution as all these things progress and come together. I think. And a lot of the magic of we're going to allow the DevOps person to completely provision the entire infrastructure, virtual routers and everything, but then someone needs to actually make it all go. And unless you can afford infinite capacity, which then it gets tricky.
So the last piece here in the analytics part I'll show you is something that's in beta right now, which is capacity planning. So what we found in a lot of tools is that if you want to explore on an interface by interface basis or get a summary of interfaces, there isn't a great way to say, just show me the interfaces that are approaching some capacity, right? I don't care about all those other interfaces. I just want to see the ones that I'm going to need to take action on within some time frame, either adding another link to my link ag or upgrading from a 10 gig to 100 gig or whatever it is. So this interface is designed to show you just the interfaces that are currently at some percent capacity or are projected to reach some percent capacity within some future time frame based on the traffic growth that we see month over month historically.
How do you get this data?
So the interface capacity comes out of SNMP, where there's an OID that'll show you the capacity of each interface or bundle. Then, because we have the flow-based traffic data for each interface, we can look at, and it does require a decently long data set to get accurate predictions, right? So the reason that we're showing trending unavailable here is because our demo account doesn't have enough data for us to make a prediction about when these interfaces are going to reach capacity. But if I were to look in some customer accounts that have a little bit more data, it actually shows a date there, a specific day when we predict that interface is going to cross 80% or 90% or whatever threshold you set over here as critical or warning.
Would you be able to provide if-else analysis based on load of the interface? So if a prepend particular IS path, what would happen to load on particular interface?
I don't think we have any way to do that directly today. I think you could run a query that would select all of the AS paths that you're adjusting, right, and quantify how much traffic that is. But it's not built into the capacity.
You've got all the data.
We do, and the what if will expand. Broadly speaking, I showed the tool slide. I think you've heard from, certainly at Networking Field Day, you've had 1,000 ISs presented, which is one kind of what if. Veriflow, I think you guys heard from. I didn't have time. I was presenting, so I didn't watch. But there's a tremendous value from what are the configs, what might break. There's also tremendous value from what's the actual traffic, what's the actual performance. And so I think it's going to be a fun evolution as those things come together. And we will be adding more what if, probably not from the configs basis. That's in our negative roadmap. We plan to integrate with people rather than do that. But the what if I move this traffic based on the data I have, not the configs, that is something we're going to continue to extend this kind of thing for. So when I make these routing changes, what will probably happen? That's not the next couple quarters, but that's something that's planned for next year. Yeah.
Comment about the capacity planning. What I see with traditional SNMP tools is data retention is a problem. There's no corporate memory. The data gets rolled up on a 6-hour, 24-hour average basis. And so what happens is people look 3 months back, try to project. And I've been telling them, look, take your data points, put them in Excel so that you can see is the curve concave up, concave down, but get some history of accuracy of your predictions as well.
Yeah, we do, for the core production data set people are generally running, keep the full resolution for 90 days. And then we do resample what we call the fast data set so people could keep years online without us having to have petabytes and petabytes. But still have some ability to go into different dimensions and look. Because again, if you only keep SNMP totals, you can't do a what if by prefix, right? Because you didn't aggregate that way. So yeah, history is important, which also drives our product people batty because because we're a SaaS company, we track adoption, what people do in the platform, but it takes a while to get history so you can actually do some of the things. So this is relatively old enough. We're just starting to get people, with months of data, but we don't have anyone with a year of data with this because we haven't had that functionality. So.
Any questions about the analytics, peering, interconnectivity before I move on to the alerting and DDoS section?
As a comment, it would be very interesting to integrate your data with traffic engineering, make it available to a PC to enrich the data used to compute a path.
And I think broadly speaking, we have customers that have made an API in front of us that translate what people think of as their TE endpoints
There you go.
to the Kentik query, but that again would just be a custom dimension that we could add. Now it's a column, which is TE endpoint, and then do matrices. So our biggest challenge is just making sure, there's a company that did network analytics, which is sort of like SAP consulting plus Hadoop for network stuff, where every deal was years to sell, years to implement, and completely custom. And so we want to avoid doing that. So we need to find the commonalities and how people are doing that. There's things we think thesis-wise people should be interested in, but if we don't have the customers asking for it, then we don't do it. But I think that definitely mapping to how you do the WAN engineering, is definitely something that people are doing, but we haven't found the commonality, and we'll do as soon as we do.